Welcome to Science for Sleep, where the wonders of the universe unfold gently and the mysteries of space become the lullabies of the cosmos. This is your safe space, a place to relax and let your mind wander, as we explore the beauty of the stars and planets in a slow, meditative rhythm. Tonight, we will embark on a peaceful journey beyond the familiar, to a world untouched by time, a world where silence and stillness reign. Together, we will float in the endless quiet of space and exploring Callisto, Jupiter's silent moon. Before we begin, don't forget to subscribe to Science for Sleep so you can drift off to more soothing explorations of the universe every night. Imagine, if you will, a slow journey out into the vastness of space. We are leaving behind the comfort of Earth, moving outward into the darkness. Earth, our home, becomes smaller and smaller, a pale blue dot hanging in the void. Slowly we drift past Mars, the red planet that has always fascinated humanity with its ancient mysteries. Mars, with its cold, dusty surface and its towering mountains, is silent as we move further from home. It's a world of extremes, vast deserts and frozen polar caps, all of which fade away as we move into the deep, dark reaches of the solar system. As we move beyond Mars, we enter the asteroid belt. It's a region scattered with remnants from the solar system's early days. Thousands of rocks, some as small as pebbles, others as large as mountains, orbit the sun in slow, deliberate paths. This is a place frozen in time, an ancient archive of the early solar system, where pieces of rock and metal tell the story of how the planets came to be. But we do not linger in this barren region. We move onward, ever outward, into the domain of the gas giants. As we approach Jupiter, the largest planet in the solar system, we feel its presence long before we can see it. Jupiter is not just a planet, it's a force of nature, and a giant that rules the inner solar system with its immense gravitational power. It is a world that draws everything to it, a gravitational king that governs the paths of comets and asteroids, and pulls its moons into its orbit. Jupiter is massive, over 11 times the size of Earth. Its gravity is so strong that it affects the orbits of everything within its reach. Its magnetic field is the largest in the solar system, and its influence extends far beyond its moons. Jupiter is not just a planet, but it is a ruler in the cosmic dance of the solar system. As we approach, we feel the tug of its gravity, gently pulling us into its orbit. Around Jupiter orbit 4 moons that are the most prominent: Io, Europa, Ganymede, and Callisto. These moons are the Galilean moons, discovered by Galileo in 1610. Each of these moons is unique, a world unto itself, shaped by the forces of Jupiter's gravity. Each moon has its own story to tell, but it is Callisto, the outermost of these moons, that stands apart. Callisto is the quiet one, the one that doesn't demand attention like its volcanic sibling Io, or the icy Europa with its potential oceans beneath the ice. Callisto is the farthest, the most distant, and the one that doesn't seem to be in any hurry. As we look toward Callisto, we can see it clearly now. It's nearly the size of Mercury, but it is not defined by dramatic features or explosive energy. Callisto's surface is old, untouched, in a time capsule of the solar system's early history. Unlike the other moons that are constantly changing due to volcanic activity or tidal forces, Callisto remains still, a silent witness to the past. We are now approaching Callisto, but before we get too close, let's take a moment to understand its place in the solar system. Callisto orbits Jupiter at a distance of 1.88 million kilometers. It takes Callisto 16.7 Earth days to complete one orbit around the gas giant. Now, that might seem like a long time, but in the vastness of space, it is a small and insignificant movement. And yet, in that slow, almost imperceptible orbit, Callisto has remained unchanged for billions of years. The moon is tidally locked, which means one side always faces Jupiter. It's as if Callisto is forever looking into the eyes of its parent planet, a constant observer, never turning away. Callisto's surface tells the story of this long, slow journey. It is heavily cratered and scarred by impacts from meteoroids and comets that have been falling on its surface for billions of years. Unlike Earth, where wind and water have worn down the craters over time, Callisto's surface remains almost pristine. There is no erosion here. There is no atmosphere to erase the past. Every crater is a snapshot in time, a record of what has happened in the solar system. When you stand on Callisto's surface, you are standing on a world that has not changed for billions of years, and a world that has been frozen in time. Callisto's discovery was not an accident. In 1610, the Italian astronomer Galileo Galilei, using his newly improved telescope, observed 4 moons orbiting Jupiter. These moons were a new revelation, and they forever changed our understanding of the universe. Until that moment, it was believed that everything in the heavens revolved around Earth. But Galileo's discovery proved that other celestial bodies had their own motions and orbits. That this was a turning point in human history, one that would lead to the realization that Earth was not the center of the universe. Galileo's discovery of the 4 moons was a monumental achievement, but it also sparked a new curiosity. What were these moons? What did they tell us about the universe? As telescopes improved over the years, scientists began to learn more about these moons, including Callisto. They learned that Callisto was the largest of Jupiter's moons, and that it had a surface unlike any other in the solar system. It was a world of quiet beauty, a place where time seemed to slow down, allowing us to explore its surface without the interruptions of volcanic activity or seismic disturbances. The discovery of Callisto and its siblings set the stage for centuries of exploration. Galileo's telescope was just the beginning. With the arrival of space probes like the Galileo spacecraft, we were able to get closer to Callisto than ever before, revealing its icy surface and deep craters. But even today, Callisto remains a mystery, a moon that holds its secrets tightly. Imagine, for a moment, standing on the surface of Callisto. It is not a world of lush landscapes or gentle winds. No, this is a world where silence reigns, where the stillness of space pervades every inch of the terrain. The air is cold, the sky above is black, and the stars are so numerous that they seem to fill the entire expanse above you. Even in the daytime, the stars are visible, tiny pinpricks of light scattered across the dark velvet sky. You take a slow step forward. The surface of Callisto is uneven, with patches of rock and ice stretching for miles in every direction. It is not a place to rush, for here, time moves slowly. As you walk, you feel the weight of gravity, a mere 0.126 times that of Earth. It's a strange sensation, not quite heavy, but enough to remind you that you're not floating freely in space. Yet the dust beneath your boots behaves strangely, lighter and slower than on Earth, but it still clings to your steps, rising in slow, languid arcs. Callisto's surface is an ancient archive of the solar system's history, its story written in scars and craters. The moon's surface is so saturated with impact craters that new ones often overlap old ones, as if the history of the solar system is layered upon itself. Every crater tells a story, and a moment in time that has been preserved for billions of years. Unlike Earth, where plate tectonics, erosion, and weather have reshaped the landscape over millions of years, Callisto's surface remains virtually untouched. There are no winds to erode the craters, no oceans to wash away the scars of time. Instead, Callisto's surface is a museum, a place where the past is frozen in place, where every impact and every collision has left an indelible mark. Though the reason for this stillness is simple. Callisto does not have the active geological processes that we see on Earth or other moons like Europa and Io. It is a dead world in terms of geological activity, a moon that has long since cooled and settled into its current state. And yet this is what makes Callisto so fascinating. It is a world that has not changed in billions of years, and in that stillness, it holds the key to understanding the early solar system. But to understand how unusual Callisto's surface is, we must compare it to Earth. On Earth, the landscape is constantly being reshaped by forces like weather, wind, and tectonic movement. Mountains are formed, eroded, and rebuilt. Oceans rise and fall, reshaping the coastline. But on Callisto, there is no erosion, no active tectonic plates, no winds to smooth the edges of the craters. The surface of Callisto is a frozen record of a time long gone. Earth's surface is young in comparison, and constantly renewing itself through the forces of nature. Callisto's surface, on the other hand, is ancient, its scars untouched by time. The craters you see today are the same craters that have existed for billions of years, waiting to tell their story. They are not just marks on the surface, they are records of the solar system's violent past. There is something deeply meditative about Callisto's surface. It is a place where time seems to stand still. That the craters are not just geological features, they are reminders of the chaos that once shaped the early solar system. They tell the story of a time when collisions were frequent, when the solar system was still in the process of settling into its current configuration. Every crater on Callisto is a snapshot of that chaotic time, preserved for eternity. Standing on the surface of Callisto, you cannot help but feel a sense of connection to the ancient past. That it is as if the moon itself is trying to communicate the story of the solar system, but in a language that is slow and deliberate. There is no rush here. Time moves differently on Callisto. And as you stand there, you are reminded that the universe operates on scales far beyond our comprehension. Let us now turn our attention to one of Callisto's most striking features, the Valhalla Basin. This is one of the largest impact structures in the solar system, and it dominates the landscape of Callisto. The Valhalla Basin spans nearly 3,000 kilometers, making it one of the largest of its kind in the solar system. It is a massive multi-ringed structure that tells the story of an ancient collision, one that shaped the moon in ways that are still visible today. The Valhalla Basin is not just a crater, it is a testament to the violence that once rocked the solar system. The central bright zone of the basin is surrounded by concentric rings, and each one a remnant of the impact that created this structure. The energy released by the impact that formed Valhalla was immense. It was a force so powerful that it created not just a single crater, but a series of concentric rings, each one a marker of the tremendous energy that was released in the collision. To put the scale of this impact into perspective, imagine the energy released by a nuclear bomb. The impact that created Valhalla would have been far more powerful, releasing an amount of energy that is difficult to even comprehend. And yet, despite the sheer scale of the event, the moon's surface remains relatively intact. The craters, the scars, the rings, they are all still here, preserved in time. Just to the side of Valhalla lies another enormous structure, the Asgard Basin. Like Valhalla, the Asgard Basin is a multi-ring impact structure, and it is just as ancient. The Asgard Basin is smaller than Valhalla, but it is no less impressive. That the structure's rings tell the story of a different impact, one that shaped Callisto in its own way. Together, Valhalla and Asgard form a striking pair of impact structures, each one a reminder of the violent history of the solar system. Both Valhalla and Asgard are examples of multi-ring basins, a feature that is common in the solar system's larger moons. These basins are created when a massive impact causes the surface to deform, creating a series of concentric rings. The rings are not just decorative features, they tell the story of the forces at work during the impact. The larger the impact, the more pronounced the rings, and the more complex the structure becomes. The craters of Callisto are not just scars on the surface, they are part of the moon's geological memory. Every crater is a timestamp, a record of the solar system's past. The surface of Callisto is a museum, and every crater tells a different part of the story. Some are small, are created by tiny meteoroids that have struck the moon over the course of billions of years. Others, like Valhalla and Asgard, are massive structures created by enormous impacts that shape the moon's surface in profound ways. The concept of geological memory is an important one, especially when it comes to moons like Callisto. Unlike Earth, where the surface is constantly changing, Callisto's surface has remained largely untouched for billions of years. Though the craters on Callisto are not just marks on the moon's surface, they are frozen moments in time, each one a snapshot of the past. The moon's surface is a direct archive of the solar system's history, a place where we can study the impacts and events that shaped the early solar system. Even today, Callisto is still being reshaped by impacts. While the moon may be geologically inactive in the traditional sense, the surface is still subject to micrometeorite bombardment. These tiny particles, traveling at incredible speeds, constantly strike the surface, creating small craters and reshaping the terrain. Over time, these impacts accumulate, slowly altering the moon's surface. The larger impacts, like those that created Valhalla and Asgard, are far less common today, but even the smallest of impacts has an effect. The surface of Callisto is not a static, unchanging place, and it is still a world in the process of slowly evolving. The moon may not have the dramatic volcanic activity of Io or the icy geysers of Europa, but it is still part of the dynamic solar system, shaped by the quiet forces of space. Here, we leave behind the familiar warmth of Earth and venture into a world where cold is the defining force. Imagine a place where the very air seems frozen, where every step you take is met with an oppressive, unyielding chill. And Callisto's temperature is not just cold, it is a kind of cold that the human body can scarcely comprehend. At minus 139 degrees Celsius, it is far colder than any place on Earth. In fact, this temperature is so extreme that even liquid nitrogen, one of the coldest substances on Earth, begins to boil at a higher temperature than this. To understand just how cold at minus 139 degrees Celsius really is, we must compare it to our own experiences. In the depths of winter on Earth, temperatures can drop to freezing around 0 degrees Celsius, and the cold can feel unbearable, but that is nothing compared to the cold on Callisto. This is a place where water ice behaves like stone. At these temperatures, water is no longer soft or malleable. Instead, it becomes hard, brittle and sharp, cracking and breaking apart under pressure. The surface of Callisto is made up of frozen water, and this ice has been there for billions of years, preserved by the deep, unyielding cold that blankets the moon. The cold on Callisto is not just uncomfortable, it is a force that shapes the entire moon. Without the warmth of an atmosphere to trap heat, Callisto is locked in an eternal winter. There are no seasons, no shifts in temperature, only the unrelenting cold that defines every inch of its surface. The sun, though it still shines from far away, is no longer a source of warmth. At Jupiter's distance, sunlight is only about 1/25 as strong as it is on Earth, and even that is not enough to thaw the ice that covers the moon. This extreme cold is the result of an effect known as the inverse square law, which governs how sunlight weakens with distance. As we move further from the sun, its light becomes weaker, and its ability to warm the planets diminishes. Jupiter is already 5 times farther from the sun than Earth, and Callisto is even further, bathed in only the faintest remnants of sunlight. Then the sunlight that reaches Callisto is far too weak to make any significant impact on the moon's icy surface. This makes Callisto one of the coldest places in the solar system, a frozen world where time seems to stand still. But cold is not just about temperature, it is about the way cold interacts with the materials around it. Cold shapes the very landscape of Callisto, preserving features that would otherwise be lost to time. The ice on Callisto's surface is not just frozen water, but it is a window into the moon's past. The ice has been locked in place for billions of years, preserving the history of the solar system in ways that are impossible on Earth. It is a place where every frozen surface tells a story. A place where cold has become the keeper of time. On Callisto, the cold does not just freeze the water, it affects everything. Metals too behave differently at such extreme temperatures. At minus 139 degrees Celsius, metals contract and become brittle. They lose their flexibility, on cracking and breaking under stress. This is a critical consideration when it comes to designing equipment for exploration. Electronics too suffer in this cold. At such low temperatures, even the most advanced technology can begin to fail. The performance of electrical systems degrades, and the materials used to build spacecraft and habitats begin to fracture and degrade. And engineering for survival on Callisto requires more than just protection from the cold. It requires understanding how cold affects every material and every system. But despite the challenges, the cold on Callisto is also what makes the moon so unique. It is a place where everything is preserved, where the landscape remains almost untouched by time. It is a place that offers us a rare opportunity to study the past, to look at a world that has remained frozen for billions of years. And it is a place where the cold is both a barrier and a window, a place that both protects and isolates. As we stand on the surface of Callisto, we are struck by more than just the cold. We are struck by the silence. This is a place where sound does not travel. There is no atmosphere to carry it. The silence on Callisto is profound, absolute, and it is a silence that stretches across the entire moon. It is a silence that fills every corner, every crater, and every frozen plain. And this is a place where the usual sensory cues that guide our understanding of the world, the wind, the sounds of movement, the hum of life, do not exist. In this deep silence, we feel the absence of everything familiar. There are no birds, no rustling leaves, no distant hum of human activity. There is only the quiet of space and the cold of a frozen world. It is a silence that stretches out forever, as endless and unbroken as the space around us. It is a silence that calms the mind, slowing it, bringing it into a state of deep reflection. The world on Callisto is not just cold, it is still. It is a world where time seems to pass differently, where every moment is drawn out and extended, where the past and the present seem to blend together. The cold on Callisto is not just a physical force, it is a psychological one. In the absence of sound, in the absence of the usual stimuli, we are left to reflect on our own existence. It is as if the moon itself is calling us to slow down, to quiet our thoughts, and to embrace the stillness of the universe. It is a place where the mind can wander, where the soul can float free from the distractions of daily life. The extreme cold on Callisto has a profound impact on the moon's landscape. Unlike Earth, where erosion, wind, and water slowly reshape the surface over time, Callisto's surface remains almost unchanged. The ice and rock that make up the moon's outer shell are frozen in place, creating a world where the past is preserved. The craters and ridges that dot the surface of Callisto have remained largely untouched for billions of years. They are like snapshots, frozen in time, offering us a rare opportunity to study the early solar system. The ice on Callisto behaves in ways that are unfamiliar to us. At these extreme temperatures, water ice becomes as hard as stone, unable to flow or shift. This means that the craters on Callisto do not slump or collapse over time as they might on Earth. They remain sharp, crisp, and well-defined. The craters on Callisto are not merely marks on the surface, they are fossils, capturing the violent history of the solar system in frozen form. The cold on Callisto is both a threat and a blessing. It is a threat to human survival, making it difficult to build anything that can function in such an environment. But it is also a blessing, because the cold has preserved Callisto in a way that is impossible on Earth. The moon's surface is a time capsule, a place where the past is preserved in perfect detail. Every impact, every collision, has been frozen in place, us to study the history of the solar system in ways that we cannot on other moons or planets. The cold on Callisto is a form of time preservation. It is as if the moon itself has been frozen in a state of stasis, waiting for us to come and explore its secrets. The cold has kept Callisto's surface intact, allowing us to study the craters and scars that mark its surface. It has preserved the history of the solar system, offering us a glimpse into the violent, chaotic past that shaped the planets and moons we see today. We find ourselves shifting our gaze not towards the icy surface beneath our feet, but upwards, toward the immense and invisible storm that surrounds the planet we have come to know. This storm is not made of clouds or rain, but of invisible forces, magnetic and charged particles swirling through space, guided by Jupiter's mighty presence. It is Jupiter's magnetosphere, the largest structure of its kind in the entire solar system, and it has a profound effect on the moons that orbit this giant planet, including Callisto. Jupiter's magnetic field is a force so powerful that it extends far beyond the planet itself. In fact, Jupiter's magnetosphere is so large that it dwarfs the size of the Sun. If you were able to look at it from a distance, Jupiter's magnetosphere would appear as a giant bubble, stretching out across millions of kilometers in space. This invisible bubble surrounds the planet, trapping charged particles from the Sun and other sources, creating a vast and complex environment of radiation. And the magnetosphere is generated by the movement of metallic hydrogen inside Jupiter's core. As this material flows, it generates a powerful magnetic field that extends well beyond the planet's atmosphere. This magnetic field is the largest of any planet in the solar system, and it has a significant impact on the moons of Jupiter. Callisto, along with the other Galilean moons, is swept up in this powerful magnetic force, orbiting within the boundaries of Jupiter's vast radiation belt. Jupiter's magnetosphere is not just a passive field, it is a dynamic, active environment. As charged particles from the Sun, mainly electrons and protons, enter Jupiter's magnetic field, they are trapped and accelerated, creating intense radiation belts that surround the planet. These radiation belts are composed of high-energy particles that are held in place by Jupiter's magnetic field, circulating around the planet in spiraling paths. The radiation belts are not static. They are constantly changing as the particles within them move and interact with Jupiter's magnetosphere. These particles are trapped in a continuous loop, moving between the poles of the planet, being accelerated and decelerated by the complex interactions between the magnetic field and the solar wind. Jupiter's radiation environment is far stronger than Earth's. Our planet is protected from the Sun's radiation by a magnetic field and an atmosphere, which shield us from most of the harmful effects. But on Jupiter and on its moons, the radiation is constant, unrelenting, and far more intense. As we consider Callisto's position within Jupiter's magnetosphere, we notice that it orbits on the outermost edge of this powerful radiation belt. Callisto is not as deeply affected by the radiation as its inner siblings, Io, Europa, and Ganymede, which are much closer to Jupiter and thus experience much higher radiation levels. But even from this distant position, Callisto is not immune. It orbits within the outer boundary of the radiation belt, where the radiation levels are lower, but still significant. The radiation on Callisto is persistent, cumulative. While it may not receive the full brunt of Jupiter's radiation, it is still subject to a steady stream of charged particles, which bombard its surface constantly. Now, this radiation is not visible to the eye, but it affects everything, from the surface features of the Moon to the technology that might be used in future missions. This radiation, although weaker than the inner moons, still presents a significant challenge for anyone hoping to explore Callisto in person. Imagine for a moment that you are standing on the surface of Callisto. The silence is profound and the cold is biting, but above you, and in the invisible world around you, there is a constant invisible storm. The radiation from Jupiter's magnetosphere is ever present, a silent companion wrapping the Moon in a constant cloak of charged particles. These particles move in the magnetic field, crashing against the surface of Callisto, and yet we cannot see them. They do not produce light or sound, but they are there, shaping the surface, affecting the materials and influencing the possibility of future missions. That radiation may be invisible, but its effects are very real. The radiation that bathes Callisto's surface is harmful. On Earth, we are protected from radiation by our atmosphere and magnetic field. But on Callisto, there is no atmosphere to shield the surface from the bombardment of high-energy particles. The radiation on Callisto is not intense enough to immediately affect human life or spacecraft, but over time it accumulates, and its effects become more pronounced. But when we think of radiation, we often think of the damage it can cause to living organisms. On Earth, radiation is a known threat, especially to cells and DNA. At high enough levels, radiation can cause mutations, cancers, and other harmful effects. On Callisto, the radiation is not strong enough to cause immediate harm to human health, but over prolonged exposure it could have significant effects. But for astronauts or any potential human mission to Callisto, the risk would be a slow, cumulative process. The radiation would slowly build up in the body, causing gradual damage over time. This is why future missions to Callisto would require significant shielding, either in the form of protective suits or shelters that could block out the radiation. Without this shielding, the effects of long-term exposure to the radiation environment could be dangerous. But radiation also affects technology. On Callisto, any spacecraft or mission equipment would need to be designed to withstand the constant bombardment of charged particles. Electronics, especially sensitive equipment like computers, sensors, and cameras, can be affected by radiation in subtle ways. As the radiation interacts with the materials inside the spacecraft, it can cause bit flips, small errors in the data stored in computers. Over time, these errors can accumulate, leading to system malfunctions or failures. Materials used in spacecraft must be chosen carefully to withstand the radiation. In some cases, this means using thicker, more durable materials or adding layers of shielding to protect delicate components. The challenge of building spacecraft that can survive in such a harsh environment is significant, but it is not insurmountable. Engineers have developed shielding techniques to protect electronics, but these come with their own set of challenges, such as the need for heavier spacecraft, which means higher fuel consumption and greater costs. One of the intriguing features of Callisto's radiation environment is that, despite being so far from Jupiter's powerful magnetic field, the Moon itself has been affected by the magnetosphere. In 1996, the Galileo spacecraft detected an induced magnetic field at Callisto, suggesting that the Moon's interior might be interacting with the radiation environment in a way that we had not fully understood before. This induced magnetic field implies that Callisto is not completely immune to Jupiter's magnetic influence, even though it is on the outer edge of the magnetosphere. This discovery raises intriguing questions about Callisto's internal composition. The fact that Callisto generates a weak magnetic field suggests that there may be something about the Moon's interior that is reacting to the radiation. Perhaps a layer of conductive material, like a liquid ocean or metallic core, that is being influenced by Jupiter's magnetic field. This finding opens the door to further exploration and deeper questions about Callisto's hidden secrets. For comparison, let us consider Ganymede, the largest moon of Jupiter, which also has a magnetic field. Unlike Callisto, Ganymede's magnetic field is intrinsic, meaning that it is generated by the Moon's own internal processes. This is a key difference between the two moons. Ganymede's magnetic field offers a form of protection from Jupiter's radiation, much like Earth's magnetic field protects us from the solar wind. But Callisto's lack of an intrinsic magnetic field does not make it defenseless. The Moon is still subject to Jupiter's magnetosphere, but it is at the outer edge, where the radiation is less intense. While it may not have the protection that Ganymede enjoys, Callisto is still in a position where its radiation environment is more manageable, but only just. The lack of an intrinsic magnetic field, combined with the presence of an induced field, tells us that Callisto is caught in a delicate balance, a moon forever influenced by the giant planet that dominates its orbit. We leave behind the frozen surface and venture below the icy shell of this ancient moon, where secrets lie hidden in the depths. It is a quiet world, yes, but beneath that quiet surface there may be something extraordinary, a subsurface ocean. The evidence for this ocean comes not from what we can see, but from what we can infer. It is a world that has been studied from afar, its hidden depths slowly revealed through the data gathered by spacecraft like Galileo. And as we stand on the surface of Callisto, we can't see the ocean below. The thick layer of ice that covers the Moon is impenetrable, but the signs of something beneath are there, waiting to be uncovered. The Galileo spacecraft, which passed by Callisto in the 1990s, provided us with one of the first pieces of evidence for this hidden ocean. Using its magnetometer, Galileo measured subtle shifts in the Moon's magnetic field, detecting what scientists have described as an induced magnetic field. This magnetic field is not something Callisto generates on its own. Rather, it is created by the interaction of Jupiter's magnetosphere with the Moon's surface. But what's most intriguing is that these magnetic signatures suggest that there is something beneath the icy surface that is capable of conducting electricity. The most likely candidate for this conductive layer? A salty, liquid ocean hidden deep beneath the ice. That this evidence, while indirect, is compelling. Salt water is an excellent conductor of electricity, and if Callisto has a subsurface ocean, it would explain the magnetic anomalies that were detected. Scientists have concluded that this ocean is likely located somewhere between 20 to 30 kilometers beneath the icy crust of Callisto, a vast cold ocean that may be isolated from the surface by a thick frozen barrier. And yet, despite the isolation, there is the possibility that this ocean could hold the key to some of the most profound questions about the potential for life in the universe. Understanding what lies beneath Callisto's surface requires a delicate process of scientific inference. We cannot directly observe the ocean beneath the ice, nor can we touch it. Instead, scientists must piece together the clues provided by the data collected from spacecraft like Galileo, and analysing magnetic fields, surface features, and other indirect measurements to form a hypothesis about what exists below. This is how science often works. We don't always have the luxury of direct observation. Instead, we must rely on the clues that the universe leaves behind, the subtle signs, the patterns, and the anomalies that, when studied carefully, tell a story. In the case of Callisto, these clues suggest that beneath the thick layer of ice, there is an ocean of liquid water, a dark and cold world that has remained hidden for billions of years. This process of scientific inference is an important reminder of the limits of our knowledge. Even as we stand on the surface of Callisto, looking out across the vast, icy plains, we know that there is more to this moon than what meets the eye. There is an ocean below, a place where conditions are unlike anything we experience on Earth. And yet, despite the vast distance and the cold, scientists are drawn to this hidden world and eager to learn more about its potential. The key to understanding the potential of Callisto's ocean lies in the nature of the water itself. The ocean is likely salty, a characteristic that would make it more conductive and capable of sustaining some form of chemistry. Liquid water is the essential ingredient for life as we know it, and its presence beneath the icy surface of Callisto raises profound questions about the possibility of life in this distant corner of the solar system. But this ocean is no ordinary body of water. It is hidden beneath a thick layer of ice, and it is likely kept at a constant temperature just above freezing, cold enough to keep the water in a liquid state, but not warm enough to sustain the conditions we associate with life on Earth. This is a world where the pressures are immense, and where the darkness is complete, and where the chemistry of the ocean may be far different from anything we can imagine. The salt in the ocean would lower the freezing point of the water, allowing it to remain liquid despite the extreme cold. But the presence of salt also raises new questions. What does this ocean mean for the chemistry of Callisto? Could it harbour microbial life despite the cold and the isolation? And could it be a world where life has managed to survive in the darkness for billions of years, shielded from the harsh radiation of space by the thick ice above? As we continue our exploration of Callisto's hidden ocean, we dive deeper into the mystery of this dark, isolated world. Imagine, if you will, the ocean beneath Callisto's surface. It is not a world of sunlight or warmth, but one of deep, unbroken darkness. There is no light here, no warmth from the sun. This ocean is completely isolated from the outside world, its only source of heat coming from the slow decay of radioactive materials deep within Callisto's interior. This ocean exists in a place far removed from the vibrant ecosystems we know on Earth. There are no plants or animals swimming in the waters, no sunlight filtering through the surface to support photosynthesis. Instead, the ocean is an abyss, cold, dark, and silent. And yet, though despite this isolation, the ocean may still have the ingredients necessary for life. There is water, there are salts, and there may be chemicals deep within the ocean that could support some form of life, however simple. The pressure at the bottom of this ocean is immense, thousands of times greater than the pressure at the surface. The water in this ocean is not like the oceans on Earth. It is under pressure, frozen in layers beneath the thick ice, and perhaps under a constant state of transformation. The ice above may press down on the water, causing it to shift and change in ways we cannot easily predict. But one thing is clear: this ocean, though hidden and isolated, is a world unto itself, cut off from the rest of the solar system. Water, as we know it, behaves differently under extreme pressure. At the surface of Earth, water is a liquid, but as we descend into the depths of the ocean, The pressure increases, and water begins to change. On Callisto, the pressure in the subsurface ocean would be even greater, causing the water to behave in unusual ways. The ocean may exist between layers of ice, with the water locked in a delicate balance, maintaining its liquid state despite the intense cold. This is a world where water is not like the water we are familiar with. It is not a warm, welcoming ocean where life can flourish in the sunlight. It is a place of darkness, where the water is cold, under pressure, and isolated. The ice above forms a barrier that shields the ocean from the outside world. But within this frozen shell, the water may still hold the key to something extraordinary, a place where life could exist in ways we can scarcely imagine. Despite the presence of liquid water, there is a sobering reality. Callisto's ocean may be slowly freezing. The heat that keeps the ocean in a liquid state is not infinite. Over time, as the internal heat of the moon decreases and the ice thickens, the ocean may begin to freeze from the bottom up. The gradual cooling of Callisto's interior means that the ocean may eventually become solid, sealing off any potential for life that might exist within it. But even as the ocean freezes, it may still harbour the last remnants of an ancient alien ecosystem. It is possible that life, if it ever existed, slowly freezes. It may preserve the slowly freezes. It may preserve the ancient chemistry of this distant world, giving us a glimpse into the distant past of the solar system. The concept of geological time is key to understanding Callisto's ocean. The moon has existed for over 4.5 billion years, and its ocean may have been present for much of that time. In the context of geological time, the slow freezing of the ocean is a gradual process, one that unfolds over millions or even billions of years. This is a world where change happens not in days or years, but in eons. The ocean may have existed for most of the moon's history, preserving a record of the solar system's early days, a place where conditions were once suitable for life to exist. As we reflect on this ocean, we are reminded of the passage of time, as it is a world that has existed for billions of years, and it will continue to exist long after we are gone. The ocean, though isolated and cold, is a reminder of the slow, steady march of time. It may be freezing, but it is still a record of the past, a place where the history of the solar system is preserved in ice and water. As we continue our exploration of Callisto, we now delve into the very heart of the moon. Not the cold surface or the mysterious ocean below, but the moon's interior, and a place where the forces of gravity, heat, and time have shaped Callisto into the world we see today. Callisto's unlike many of the other moons in the solar system, particularly its inner neighbours. It is a world that never fully finished its formation, a moon that holds within it the echoes of the early solar system, frozen in place and awaiting to tell its story. At first glance, Callisto may seem like a simple moon, a distant, quiet world that has remained unchanged for billions of years. But when we look closer, we see that its interior is a mystery. Unlike Earth, which has a well-defined core, mantle, and crust, Callisto's interior is far less differentiated. This means that Callisto never fully underwent the process that most planets and moons go through, the process of differentiation, where the materials in a world separate based on their density, with heavier materials sinking to the center to form a core and lighter materials rising to form the crust. Instead, Callisto's interior is a blend of rock and ice mixed together in a way that suggests it never experienced the same kind of internal heating that its larger neighbors did. The result is a moon that, while massive in size, is not as well structured as other bodies in the solar system. This lack of differentiation means that Callisto is not a fully formed world, but rather a relic of the early solar system, a place where the forces that shape the planets never fully took hold. But to understand what makes Callisto so unusual, we must first understand the process of differentiation. In most planets and moons, the process of differentiation begins shortly after they form. As a world begins to cool, its materials begin to separate. The heaviest materials, like metals, sink to the center to form a core. Lighter materials, like silicates and ices, rise to the surface to form the crust. This process creates a layered structure, and with a dense, metallic core at the center. surrounded by a rocky or icy mantle and crust. Differentiation is a crucial process for many planets and moons because it allows for the formation of a stable internal structure. The separation of materials also has important implications for the planet's geology, atmosphere, and even its potential to support life. The Earth, for example, has a molten iron core that generates a magnetic field, protecting us from the harsh radiation of the Sun. And this magnetic field is essential for life on Earth, as it shields the surface from the dangerous solar radiation. But Callisto never fully underwent this process. Instead, its interior remains a blend of rock and ice, slowly mixing together over billions of years. This lack of differentiation means that Callisto's interior is not as stable as other moons and planets. There is no dense metallic core, no clear division between the different layers of the moon. Instead, Callisto's interior is a mix of materials, gradually transitioning from rock to ice without any sharp boundaries. Despite this lack of differentiation, scientists have been able to learn a great deal about Callisto's interior using gravity measurements from spacecraft flybys. The Galileo spacecraft, for example, conducted a series of flybys of Jupiter's moons, including Callisto, and measured the moon's gravity. These measurements provided key insights into Callisto's interior structure, showing that the moon is partially differentiated, that is, it has some degree of layering, but not to the extent that we see in more geologically active moons like Europa or Io. The data suggests that Callisto's ice and rock are mixed together in a way that creates a less defined structure. The ice is not a uniform layer on top of a solid core, as it is on other moons. Instead, the ice and rock are intertwined, but gradually transitioning from one material to another. This slow, uneven process of differentiation suggests that Callisto formed differently than other moons, and it is this difference that gives the moon its unique character. As we reflect on Callisto's incomplete formation, we are faced with the consequences of this unique history. Callisto is not a fully differentiated world, and this has profound implications for its structure, its geology, and its future. One of the key consequences of Callisto's incomplete differentiation is the absence of a metallic core. On Earth, the core plays a crucial role in generating the planet's magnetic field. This magnetic field protects us from the solar wind, the stream of charged particles emitted by the Sun. It is essential for life on Earth, and as it shields the surface from harmful radiation and helps to maintain a stable environment. But Callisto lacks this protective magnetic field. Without a metallic core, Callisto cannot generate the same kind of dynamo effect that powers the magnetic fields of other moons like Ganymede. This absence of an intrinsic magnetic field is a key feature of Callisto's lack of geological activity, while Ganymede, for example, has an active magnetic field that helps protect it from the harsh radiation of Jupiter's magnetosphere. Callisto is left exposed to the constant bombardment of charged particles. The radiation from Jupiter's magnetosphere is much weaker at Callisto, but it is still a constant presence, affecting the moon's surface and the internal structure. This lack of protection from radiation is a reminder of Callisto's status as a moon that never fully finished forming, a world that is not fully equipped to deal with the forces around it. Another consequence of Callisto's incomplete differentiation is the lack of tidal heating. Tidal heating occurs when the gravitational pull of a planet or moon creates friction within its interior, causing heat to build up. On moons like Europa and Io, which are closer to Jupiter, tidal heating is a major factor in shaping their geological activity. For Europa, it is this tidal heating that keeps its subsurface ocean liquid, allowing it to remain a potentially habitable world. But Callisto does not experience the same level of tidal heating. It has a nearly circular orbit, which means that the gravitational forces exerted on it by Jupiter are relatively weak. As a result, there is little internal friction to generate heat. But Callisto's interior remains cold and stagnant, and without this internal heating, the moon lacks the kind of geological activity seen on other moons like Io and Europa. There are no volcanic eruptions, no tectonic plates shifting, and no active processes reshaping the surface. Instead, Callisto is a world that has cooled and settled, a place where the forces that shaped other moons never fully took hold. And this lack of geological activity also means that Callisto is a thermally aging world. Over billions of years, the moon has cooled and contracted, its interior slowly becoming more rigid and brittle. The lack of internal heat has caused Callisto to become more and more solid over time, with fewer opportunities for new processes to take place. The surface of Callisto is covered in ancient impact craters, those scars left by the collisions of meteoroids and comets. These craters are not just marks on the surface, they are remnants of a time when the solar system was still young and collisions were frequent. But Callisto's surface is not just a collection of scars. It is also a world that is slowly becoming more rigid and unyielding. The lack of heat has caused the moon to cool, and as it does, the surface becomes more and more solid. Callisto's interior, too, is slowly becoming less active, as the cooling process continues over millions and billions of years. This makes Callisto a world that is defined by what it never became, a moon that never fully formed, never fully differentiated, and never became the active world that its siblings did. As we reflect on Callisto's incomplete formation, we are reminded that some worlds are defined by what they never became. Callisto is not a failure, but rather a reminder of the cosmic forces that shape all bodies in the universe. It is a moon that has been shaped by time and circumstance, not by the intense processes that define other worlds. It is a world that never fully underwent the process of differentiation, never fully experienced the heat and energy that shaped other moons and planets. In many ways, Callisto represents a snapshot of the early solar system, a place where the forces of formation were still at play. And its incomplete structure is a reminder of the chaotic early years of the solar system, a time when planets and moons were still being shaped by their collisions and interactions. Callisto is not just a moon, it is a window into the past, a place where we can see what happens when worlds form slowly and without the intense forces that shape other moons and planets. As we drift deeper into the history of Callisto, we move back in time to a chaotic period, a time when the solar system was still in its infancy, when collisions and impacts were a common occurrence, and when the worlds we know today were still taking shape. This period, known as the Late Heavy Bombardment, occurred roughly 4 billion years ago, and it was a time when the solar system was anything but peaceful. Instead, it was a time of chaos, when asteroids, comets, and other objects from the outer solar system were frequently colliding with the planets and moons in a violent cosmic dance. During the Late Heavy Bombardment, the solar system was still in the process of settling into its current configuration. The planets and moons were not yet fully formed, and their orbits were not yet stable. As a result, they were constantly bombarded by debris left over from the formation of the solar system. These impacts were not small, they were massive, world-changing events that shaped the surface of the planets and moons, leaving behind scars that can still be seen today. Callisto, being one of the largest moons in the solar system, was no exception to these impacts. In fact, its heavily cratered surface is a direct result of this violent period in the solar system's history. Every crater on Callisto tells the story of an ancient collision, a snapshot of a time when the solar system was still a young, chaotic place, where everything was in motion. The role of Jupiter in the Late Heavy Bombardment is a particularly important one. As the largest planet in the solar system, Jupiter's massive gravity had a profound effect on the smaller bodies in the outer solar system, including comets and asteroids. Jupiter's gravity acted as a gravitational slingshot, redirecting these objects and sending them hurtling towards the inner solar system. And some of these objects collided with the planets and moons, including Earth, Mars, and the moons of Jupiter, including Callisto. In many ways, Jupiter was both a creator and a destroyer during this period. Its gravity helped shape the solar system by influencing the orbits of smaller objects, but it also contributed to the destruction of the early moons and planets. The impacts from these objects created the craters we see today on Callisto's surface, and they also caused significant damage to other moons in the Jovian system, including Io, Europa, and Ganymede. Callisto, however, appears to have been less affected by volcanic activity than its neighbours. Instead, it bears the scars of the impacts that shaped the Moon during the bombardment era. Imagine for a moment standing on the surface of Callisto during this time. The sky above you would not be the quiet, peaceful sight that we see today. Instead, it would be filled with objects in motion, colliding with each other and creating flashes of light as they impacted the surface. The night sky would have been a chaotic place, filled with streaks of light from meteoroids and asteroids as they entered the atmosphere and collided with the surface. The landscape around you would be constantly changing, with new craters being formed as objects from the outer solar system crashed into Callisto's surface. The impacts that occurred during the late heavy bombardment were not rare, they were frequent, and they would have shaped Callisto's surface in profound ways. Every crater on Callisto is a record of these ancient collisions, a window into a time when the solar system was still in turmoil. Despite the distance between us and this chaotic period in the solar system's history, the scientists have been able to learn about the late heavy bombardment through the study of the craters on the surfaces of planets and moons. By counting the number of craters and analysing their size and distribution, scientists can estimate the frequency and intensity of impacts during this period. The older and more heavily cratered a surface is, the more likely it is to have been affected by the bombardment. Callisto, with its heavily cratered surface, is a prime example of this process. The craters on its surface are some of the oldest and most well-preserved in the solar system. They offer a direct record of the late heavy bombardment and provide valuable insights into the early history of the solar system. By studying these craters, scientists can learn more about the events that shaped Callisto and its neighbours, and gain a deeper understanding of the forces that shaped our cosmic neighbourhood. As we move beyond the late heavy bombardment and the chaos it brought, we realise that the solar system is not finished with its violent past. While the late heavy bombardment was one of the most intense periods of impact, it did not mark the end of cosmic collisions. Today, the outer reaches of the solar system are still filled with objects that could potentially collide with the planets and moons. That these objects are part of what we call the Kuiper belt and the Oort cloud, regions of space that contain remnants from the early solar system. The Kuiper belt is a region beyond Neptune that is populated by icy bodies, comets, and other small objects. Some of these objects are small, while others are large enough to be considered dwarf planets, like Pluto. The Oort cloud, located even farther from the Sun, is a distant reservoir of icy objects that have been sent out into the farthest reaches of the solar system by the gravitational influence of the planets. Together, the Kuiper belt and the Oort cloud are the last remnants of the early solar system, and they continue to send objects into the inner solar system. In 1994, the world watched in awe as comet Shoemaker-Levy 9, which had been captured by Jupiter's immense gravity, collided with the planet. But the event was a dramatic reminder of the dangers that still lurk in the outer solar system. The impact caused massive explosions on Jupiter's surface, sending up plumes of gas and debris. This event showed us just how vulnerable the solar system is to impacts even today. While we may not see the same level of bombardment that occurred during the late heavy bombardment, the possibility of an impact still exists. Shoemaker-Levy 9 was a rare and dramatic event, but it serves as a reminder that the solar system is not a quiet, stable place. Even today, objects from the outer solar system are still on their way toward the inner planets and moons. While most of these objects will miss their targets, some may still collide with the moons of Jupiter, including Callisto. This is why the study of craters on Callisto's surface is so important. They tell us about the past, but they also serve as a warning for the future. But while the late heavy bombardment may have been the most intense period of impacts, it was not the last. The outer solar system is still filled with comets and asteroids that could potentially collide with the moons of Jupiter. In fact, Callisto is still subject to micrometeorite bombardment, even today. These tiny particles travel through space at incredible speeds, and when they strike Callisto's surface, they create small craters and scars. Although these impacts are less dramatic than the ones that shaped Callisto during the late heavy bombardment, they still have an effect. Over time, these smaller impacts accumulate, reshaping Callisto's surface, just as the larger impacts did billions of years ago. It is a slow process, but it is still happening. Callisto's surface may be old and heavily cratered, but it is not finished. It continues to be shaped by the objects that drift through the dark void of space. And most of the impacts that occur today on Callisto's surface are the result of micrometeorites. These tiny objects are fragments of comets and asteroids that have been floating through the solar system for billions of years. Though small, these micrometeorites are travelling at incredibly high speeds, often several kilometres per second, and they strike Callisto's surface with tremendous force. Over time, these tiny impacts accumulate, reshaping the surface in subtle ways. While micrometeorite impacts may not create the dramatic craters we associate with the late heavy bombardment, they are still an important factor in Callisto's ongoing geological evolution. The craters created by these impacts may be small, but they are a constant reminder that the solar system is not a static place. It is a dynamic, an ever-changing environment where collisions are still. We turn our attention to one of the most profound questions humanity has ever asked. Could there be life on this distant moon? It's a question that has been at the heart of many space missions and scientific studies, the search for life beyond Earth. As we stand on the surface of Callisto, looking out over the vast silent landscape, we must pause and reflect on what makes a world capable of supporting life. We know that life, and as we understand it, requires certain conditions: liquid water, chemical energy, organic molecules, and time. These are the building blocks that make life possible, and they are what scientists look for when searching for extraterrestrial life. On Earth, these conditions exist in a delicate balance, allowing life to thrive in diverse and extraordinary ways. But what about Callisto? Callisto is far from Earth in both distance and environment. It is a world that exists in eternal darkness, its surface frozen beneath a thick layer of ice. The surface temperature is far below freezing, making it seem an unlikely candidate for life. Yet beneath this icy shell, scientists believe there may be a hidden ocean, a vast, cold and dark ocean that might contain the ingredients necessary for life. If life could exist here, it would be unlike anything we've ever known, adapted to extreme cold, pressure and darkness. So what makes Callisto's ocean a possible home for life? An ocean, though cold and dark, may have the essential ingredient for life: liquid water. Water is a key solvent in the chemical reactions that drive life, and its presence in Callisto's ocean opens the door to the possibility of life, even in the harshest of environments. While water is crucial, the life also needs a source of chemical energy to fuel its processes. On Earth, many ecosystems thrive around hydrothermal vents, fissures in the Earth's crust that release heat and chemicals into the ocean. These vents provide the energy that sustains life in some of the most extreme conditions on Earth, far from sunlight. But Callisto's ocean is not in direct contact with rock, and so the possibility of similar vents seems unlikely. However, there are still other sources of chemical energy that could support life. One possibility is that the ice surrounding Callisto's ocean might undergo reactions under pressure, releasing gases and other compounds into the water below. These compounds could provide the chemical energy necessary for life to thrive, even in the absence of sunlight. But Callisto's ocean is isolated. There is no natural way for sunlight to reach it, and there is no active process like tidal heating to provide a constant source of energy. Life here would need to adapt to survive without the warmth and light that most life forms on Earth depend on. It would have to be a slow, efficient form of life, capable of surviving on a minimal energy. Life on Callisto, if it exists, would be in complete isolation from the rest of the solar system. There would be no way for organisms to exchange genetic material, no ecosystem to sustain them. This would be a world entirely separate from Earth with its own unique forms of life, if any. The conditions on Callisto are extreme, but they are not impossible. Earth is home to life forms that thrive in extreme environments, in the depths of the ocean, in the frozen tundra, in boiling hot springs. These extremophiles show us that life is more adaptable than we once thought. And if life can survive in the harshest environments on Earth, then it's possible that the similar forms of life could exist in Callisto's ocean, adapted to the cold, dark and isolated conditions of this distant moon. But the idea of life on Callisto raises more questions than it answers. If life does exist, What would it look like? Would it be microbial, like the earliest forms of life on Earth? Or could it be something more complex, perhaps a form of life that we cannot even imagine? So the very nature of life in such a hostile environment would be fundamentally different from anything we know. It would challenge our understanding of biology, chemistry, and the limits of life itself. As we ponder the possibility of life on Callisto, we must also consider the ethical implications of exploring such a world. The question of life on other planets or moons is not just a scientific one, it is also a moral one. If we were to discover life on Callisto, even microbial life, then it would force us to reconsider our role in the universe and how we interact with other worlds. Planetary protection is a key issue when it comes to the search for life beyond Earth. If life does exist on Callisto, we must ask ourselves, what responsibility do we have to protect it? As human explorers, we must be careful not to contaminate the environments we study. Even the smallest trace of earthly microorganisms could pose a threat to native life on Callisto. And once we introduce our own organisms into the environment, there is no turning back. The potential for contamination is irreversible. This is why planetary protection protocols are so important. These protocols are designed to ensure that we do not inadvertently bring Earth's microbes to other worlds, where they could disrupt any potential ecosystems. The ethical implications of this are far-reaching. If we discover life on Callisto, we will have to carefully consider how we proceed. But we may be forced to leave this hidden world untouched, to protect it from our own influence, even if we are eager to study it. Once we introduce life from Earth to another planet or moon, it cannot be undone. The bacteria and other microorganisms we carry on our spacecraft are resilient. They can survive in the harshest environments, and that they could potentially interfere with any native life on Callisto. Even the smallest contamination could alter the course of evolution on that world. For this reason, any mission to Callisto would need to be carefully controlled, with rigorous sterilization processes and safeguards in place to prevent contamination. The ethical responsibility is clear. If life exists on Callisto, we must approach the discovery with great care and respect. The discovery of life on another world would be one of the most profound moments in human history, but it would also come with great moral weight. The question of life on Callisto is not just about science, and it is about understanding our place in the universe and our responsibility to protect the worlds we explore. The possibility of life on Callisto is more than just a scientific question. It is a question that touches on the deepest parts of our humanity. What does it mean to find life beyond Earth? What does it mean for our understanding of the universe and our place within it? If life exists on Callisto, it would show us that life is not a unique phenomenon to Earth, but something that could arise in the coldest, darkest, and most isolated corners of the cosmos. The philosophical weight of this discovery would be immense. It would force us to reconsider our understanding of life, its origins, and its potential. It would open up new possibilities for the future of humanity and our exploration of the stars. And it would raise profound ethical questions about how we interact with the worlds we visit. As we leave the silent, frozen world of Callisto behind, could we carry with us the question that has lingered throughout this journey? Could life exist in its hidden ocean? The answer, we may never know. But the possibility is enough to inspire us, to remind us that the universe is full of mysteries waiting to be uncovered. Life, as we understand it, may be rare in the universe. But the search for it, the question of its existence, will continue to drive us to explore the farthest reaches of space, to uncover the secrets of distant moons like Callisto. And as we drift off into the night, we are reminded that the search for life is not just about finding answers. It is about asking the right questions and allowing those questions to guide us deeper into the unknown. As we prepare to embark on an imagined journey to Callisto, we are reminded that this is not a place for the faint-hearted. It is a world that exists far from Earth, on the outer fringes of the solar system. The journey to Callisto, if it were to happen, would not be a short one. And it would take years, perhaps as many as 6, to reach this distant moon, and every moment of that journey would test the limits of human endurance, technology, and spirit. The spacecraft that would take us on this journey would have to be specially designed for the long voyage. There would be no quick shortcuts in space travel. Unlike the relatively short trips to the Moon or Mars, A journey to Callisto would require advanced propulsion systems, life support technologies, and radiation protection. And once we begin the journey, there would be no turning back. The vast emptiness of space stretches out in all directions, and Callisto is so far from Earth that communication would be delayed by up to 52 minutes, nearly an hour, making real-time communication impossible. The first step of the journey would begin on Earth, where the spacecraft would launch, escaping our planet's gravity and setting off toward Jupiter, Callisto's parent planet. Along the way, lads of the spacecraft would have to navigate the gravitational complexities of the solar system, using gravity assists from the planets to increase speed and adjust its trajectory. These complex maneuvers, known as slingshot trajectories, are essential to conserve fuel and ensure that the spacecraft reaches its destination. Once the spacecraft enters the orbit of Jupiter, the real challenge begins, slowing down enough to enter the Jovian system and approach Callisto without overshooting. Callisto, and despite being the outermost of Jupiter's moons, is still subject to the massive gravitational pull of the gas giant. The spacecraft would need to carefully adjust its velocity, using thrusters and gravity assist to enter orbit around Callisto. This would be a delicate process, and the slightest error could result in the spacecraft being lost to the vastness of space. Once the spacecraft successfully reaches Callisto, the landing process would begin. Unlike Mars, which has a thin atmosphere that can slow a spacecraft down, Callisto has no atmosphere to speak of. There is no cushion of air to slow the descent. Instead, the spacecraft would have to use its thrusters to slow its fall, making a controlled landing on the icy surface. The lack of atmosphere on Callisto means that there would be no aerobraking, no parachutes or atmospheric drag. Everything would depend on the spacecraft's engines, carefully modulated to ensure a soft landing. And as the spacecraft descends toward Callisto's surface, the icy landscape would come into view, stark and beautiful. The surface would be illuminated by the faint light of Jupiter, casting long shadows across the frozen plains. From the window, the first glimpse of Callisto's surface would be nothing short of awe-inspiring. It is a world that has remained untouched for billions of years, a place where time has stood still, and yet despite the stillness, there is a sense of life here, a quiet beauty that calls to the explorer in all of us. One of the immediate challenges that any human presence on Callisto would face is the issue of power. The distance from the sun means that solar power would be ineffective, and the amount of sunlight reaching Callisto is a fraction of what Earth receives. Instead, nuclear power would likely be the primary energy source for any missions to Callisto. Nuclear reactors could provide the necessary power for the spacecraft and for any habitat that would be established on the surface. Another key consideration is the availability of water. On Earth, water is essential for life, but on Callisto, water would need to be extracted from the moon's surface ice. This would involve mining the icy surface, melting it, and then filtering it for use. While the presence of water on Callisto is one of the reasons that life could potentially exist here, and it also presents significant challenges for human explorers. Water is not just for drinking, it is needed for food production, waste recycling, and even for generating oxygen. Extracting and utilizing this precious resource would be key to sustaining human life on Callisto. The physical challenges of getting to Callisto are immense, but the psychological challenges may be even greater. The journey itself would take years, and once the spacecraft lands, the crew would be isolated from Earth in a way that no astronaut has ever been before. The psychological strain of isolation would be profound. Communication delays, lasting up to 52 minutes for a round-trip signal, would make it impossible to have real-time conversations with loved ones or mission control. Every message would take more than an hour to receive, and every decision would be made with the knowledge that there could be no immediate assistance. That the isolation of the mission would be unlike anything experienced on Earth. There would be no quick trips back to the safety of Earth, no way to quickly escape if something went wrong. The crew would be completely reliant on their spacecraft and their habitat for survival, with little chance of outside help. This would require a level of mental fortitude that is hard to imagine. The crew would need to rely on each other, forming close bonds that would help them endure the long months and years of isolation. In addition to the isolation, the physical environment of Callisto would present its own challenges. The lack of atmosphere means that there is no protection from the radiation of Jupiter's magnetosphere. Even at Callisto's distance from the planet, the radiation levels are still high enough to pose a threat to human health. Shielding would be necessary to protect the crew, and the spacecraft and habitat would need to be designed to withstand the constant bombardment of charged particles. The cold would also be a constant challenge, with temperatures averaging around -139 degrees Celsius. Callisto is one of the coldest places in the solar system. Even inside the spacecraft or habitat, the crew would need to maintain a carefully controlled environment to prevent the equipment from freezing. The extreme cold would also make it difficult to work outside, limiting the amount of time the crew could spend on the surface of Callisto. Every task would need to be carefully planned with limited time for exploration or research. One of the most significant threats to human exploration of Callisto is the radiation environment. Jupiter's magnetosphere creates a radiation belt around the planet that extends out to Callisto. While the radiation levels at Callisto's distance from Jupiter are lower than at the closer moons, they are still high enough to pose a significant risk to human health. The radiation on Callisto is not like the radiation on Earth, where the atmosphere and magnetic field provide protection. On Callisto, there is no such shield, and the crew would be exposed to the radiation for the entire duration of their stay. This would require a new level of protection. The spacecraft and habitat would need to be shielded from the radiation, perhaps by burying the habitat beneath the surface ice, or using materials that could block the radiation. Even with shielding, however, the crew would still be exposed to some degree of radiation, and the long-term effects of this exposure are not fully understood. This is one of the key challenges that future missions to Callisto would need to address. Despite the many challenges, there would also be moments of awe during a mission to Callisto. The view of Jupiter from the surface would be unlike anything seen from Earth. Jupiter would rise above the horizon, its swirling clouds and great red spot visible even to the naked eye. The sheer size of the planet would dominate the sky, a constant reminder of the gas giant's power and presence. The view of the stars would be equally breathtaking. On Earth, the light pollution of cities often obscures our view of the stars, but on Callisto, the sky would be free of such distractions. But with no atmosphere to scatter light, the stars would shine brighter than ever before. The Milky Way would stretch across the sky in a brilliant band of light, offering a sense of perspective and wonder that is impossible to experience on Earth. As we leave behind the imagined surface of Callisto, we are reminded that exploration is not just about reaching distant worlds. It is about understanding the limits of human endurance, both physical and mental. The challenges of surviving on Callisto are immense, and the journey to this distant moon would push the boundaries of what we are capable of achieving. But despite the obstacles, there is something deeply compelling about the idea of exploring Callisto. It is a world that is as mysterious as it is beautiful, a place that has remained untouched for billions of years. The possibility of human exploration of Callisto, though distant, offers us a glimpse into the future, a future where humanity reaches out to the farthest corners of the solar system, driven by curiosity and the desire to understand our place in the universe. The journey to Callisto would not be easy, but it would be one of the most profound adventures in human history, reminding us of the power of exploration and the unrelenting drive to seek out the unknown. As we stand on Callisto's surface, contemplating its history, but we are reminded that this frozen moon is not just a relic of the past, it's a part of the future as well. Callisto has existed for over 4.5 billion years, and it will continue to exist long after the human race has faded from the pages of history. The forces that shaped Callisto, the cosmic collisions, the tidal forces of Jupiter, the gradual cooling of its interior, will continue to shape the moon for billions of years to come. And one of the most intriguing aspects of Callisto's future is its slow orbital drift. Callisto, like many moons in the solar system, is slowly moving away from its parent planet Jupiter. This process is incredibly slow, occurring at a rate of just a few centimeters per year. While this might seem insignificant, over the course of billions of years, this movement will add up. In the distant future, Callisto will be much farther from Jupiter than it is today, and the gravitational relationship between the two bodies will have changed in ways we can't fully predict. This gradual drift is part of a larger cosmic process. The moons of the gas giants are slowly moving outward, and their orbits are gradually becoming more circular. This is a process known as tidal evolution, and it is driven by the gravitational interaction between the planet and its moons. As the moons move farther from their parent planets, they experience less tidal heating and less gravitational influence, leading to a cooling of their interiors and a slowing of their internal processes. The eventual outcome of this process is that Callisto will drift farther and farther from Jupiter, leaving behind the powerful gravitational forces that have shaped it for so long. Eventually, this will result in a significant change in Callisto's orbit and its relationship to Jupiter. While this process will take billions of years, it is a reminder that even the most stable moons are subject to the slow, inexorable pull of time. But Callisto's future is not solely determined by its relationship with Jupiter. The Sun, too, plays a significant role in shaping the future of the solar system. The Sun, like all stars, has a finite lifespan. In about 5 billion years, it will run out of fuel and begin the process of dying. As the Sun ages, it will expand, becoming a red giant. This expansion will have profound consequences for the inner planets, and for Callisto as well. When the Sun becomes a red giant, it will expand far beyond its current size, possibly engulfing the inner planets, including Mercury, Venus, and Earth. While Callisto is far enough from the Sun that it is unlikely to be engulfed by the expanding star, the effects of the Sun's transformation will still be felt. As the Sun swells, its increased luminosity will warm the outer solar system, causing Callisto's icy surface to sublimate and lose its volatiles. This warming will likely have a significant impact on Callisto's ocean as well. As the temperature rises, the ice that covers the moon will begin to melt, possibly causing the subsurface ocean to warm. Over time, this could lead to the slow release of gases and volatiles, altering the chemical composition of the ocean and possibly making it more habitable for life. But this is still billions of years away, and by the time this happens, Callisto may be a frozen world, its ocean long gone. As the Sun's expansion slows and the system cools, the outer solar system will begin to feel the effects. Callisto, far from the warmth of the Sun, will continue its slow drift away from Jupiter, and its surface will continue to freeze. The ice will thicken, and the ocean below, if it still exists, will slowly freeze as well. Eventually, Callisto will become a completely frozen world, and its surface an ocean locked in eternal cold. This gradual freezing is part of the natural cycle of planetary bodies. Planets and moons cool over time, and as they do, they become more rigid and less active. Callisto, which has already experienced billions of years of cooling, will continue this process. The lack of internal heat, the slow movement of the moon outward, and the cooling of the Sun will all contribute to Callisto's eventual state as a cold, dead world. But this process will take billions of years, and for much of that time, Callisto will remain a silent witness to the passage of time, observing the slow changes that occur in the solar system around it. As we contemplate Callisto's long-term fate, we are reminded of the concept of deep time. The universe operates on scales of time that are almost beyond our comprehension. We live in a world where a human lifetime is measured in decades, and even the history of civilization stretches back only a few thousand years. But in the vastness of the cosmos, these scales of time are insignificant. Callisto, a moon that has existed for over 4.5 billion years, will continue to exist long after we are gone. In the grand scheme of deep time, Callisto is a patient world. It does not rush or change quickly. It endures. Even as the solar system changes around it, Callisto remains relatively unchanged, and a constant in a universe that is constantly in flux. The ice on its surface has been there for billions of years, and though it will eventually thaw and freeze again, the moon's endurance is a testament to the slow, unyielding passage of time. As we stand on Callisto's surface, we can't help but feel the weight of time. It is not a weight that presses down on us, but rather a weight that pulls us into a deep sense of reflection. So Callisto is a world that has witnessed the birth of the solar system, the formation of planets and moons, the rise of life on Earth, and the eventual cooling of its own surface. And yet, it is a world that has remained relatively unchanged, a silent witness to the passage of eons. Callisto's craters, its scars, its icy surface, all of these are markers of the deep time that shapes the moon. The craters are not just remnants of ancient collisions, they are records of the past, frozen in place. They're waiting for us to decipher them. Each crater tells a story of a time long gone, yet still preserved in the ice and rock of Callisto's surface. And as we look at these craters, we are reminded of the enduring nature of the moon itself. Callisto has seen so much, and yet it remains as it always has been, a quiet, patient world. In the grand cosmic scheme, Callisto is just one of many moons, one of many worlds that exist in the vast emptiness of space. But even in its quiet, isolated existence, Callisto has a place in the universe. It is a world that has endured the passage of time, a world that will continue to endure long after the sun has died and the solar system has cooled. In the face of all the chaos and violence of the universe, Callisto remains a calm, silent witness to the story of the solar system. This indifference of the universe is not a frightening thing, but rather a peaceful one. The universe continues whether we watch or not. And it is a reminder that we too are part of this cosmic cycle, a cycle of birth, change, and eventual decay. And as we gaze out across the frozen surface of Callisto, we are reminded of the quiet future that awaits. It is a future where time moves slowly, where the cycles of nature continue, and where worlds like Callisto endure, unchanging for billions of years. In the end, Callisto will continue to orbit Jupiter, quietly drifting through space. It will not rush, it will not change, but it will continue to exist. It will be a world that remains frozen in time, waiting for the next chapter in the story of the solar system. And as we drift away from Callisto, we are left with the knowledge that this silent moon, this patient world, will endure for billions of years to come. Callisto is not a world of dramatic changes, of explosive events or sudden shifts. It is a world of deep time, of slow processes and gradual change. It is a world that endures, and in that endurance, yet it teaches us something profound, that even in the vast, indifferent universe, there is beauty in stillness, in patience, and in the quiet passage of time. As we slowly dissolve into the quiet of deep space, we are reminded of Callisto's place in the universe, a place that has stood the test of time and will continue to stand for billions of years. In the vastness of space, Callisto is but a small, quiet moon, but in its silence it holds the stories of the past and the future. Tonight, that we leave Callisto behind, but we carry with us the lesson of endurance, the lesson that time moves slowly in the universe, and that even in the quietest of worlds, there is meaning, there is history, and there is beauty. As we drift off into sleep, we are reminded that the universe continues, whether we watch or not, and that in that quiet eternity there is peace.